All right, so last up in this section is something called the intermediate value theorem. And you will see something akin to this again in calculus if you go on to calculus. So intermediate value theorem basically says if we've got some polynomial p of x, so this is just some, random polynomial here, p of x, and 2 points, a and b, that are not the same. If p of a and p of b, so let's just say, you know, this is, here's a, so p of a, and here's b, so p of b is here. So obviously p of a and p of b have opposite signs. Then this means that there's at least one real zero in between x equals a and x equals b. In other words, the graph has to go through the x-axis to get from positive to negative. Very simple here, right? That's what this is saying. So in this case, you know, well, I didn't pick x equals 4 or negative 4 because it was off the graph, but p of negative 4 is obviously positive, p of negative 2 is obviously negative. There has to be a real zero somewhere between those two numbers. Of course, somebody calls me in the middle. Okay. So this is useful with things like numerical methods where it's like you have no idea where the root is. So, you know, pick 2 points, see if the signs are opposite, and then you basically do kind of like a search function. Those of you who have taken computer science know a couple of different ways to do searches, and you can kind of narrow down that interval over and over and over again until you find the actual root. But we're not doing that. We're just using this as justification to verify whether or not there is a zero in between 2 points. So for instance, here we have a quadratic, and we know it's doing something. And I can't factor this thing right off the top of my head. So we want to say, okay, do we know for sure if there's a zero between x equals 2 and x equals 3? So we're going to say, okay, great. Let's try it. Okay. My pen, it works great all day, and then it doesn't want to work. So f of 2, we're going to say, okay, what is that? 3 times 2 squared minus 2 times 2 minus 11. That is 12, right? 3 times 4 minus 11, which will be negative 3. And f of 3 is going to be 3 times 3 squared minus 2 times 3 minus 11. So that's going to be 3 times 9, which is 27, right? Minus 6 minus 11, that will be 10. So we can look at that and say, well, the function goes from negative 3 to positive 10. It's got to cross through 0, right? So since f of 2 and f of 3 are opposite signs, there must be at least one zero between x equals 2 and x equals 3. Now, unfortunately, if the signs are the same, doesn't tell you anything, right? Because you could say, I'm going to try this x, and the sign's the same, and there's actually 2 zeros in there, right? So this theorem doesn't work the other way. Okay. So this one, we just got a second example here. Use the intermediate value theorem to confirm there's at least one zero between a equals negative 1 and b equals 1. So we're going to do exactly the same thing. We're going to plug in negative 1. And we're going to simplify that. So negative 2 times negative 1 minus negative 1. There we go. So this is going to be 2 plus 1, which is 3. F of 1, we're going to plug in negative 2 times 1 cubed minus 1. So we've got negative 2 minus 1, which is negative 3. And so again, the same story. 3, -3 are opposite signs. So since f of -1 and f of 1 are opposite signs, there is at least 1, 0 between x equals -1 and x equals 1. So if you had this on the test, that's what you need to say. You need to show that the function's opposite signs, and then just say, well, hey, since they're opposite signs from the intermediate value theorem, I know there's at least 1, 0 in between those two x values. Pretty straightforward. Don't overthink it, right? And that is the end of this chapter.